What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. 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 I got a rock. I got a rock. I got a rock. Rock. Rock.
What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock.
What did you What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock. Got a rock. 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 I got a rock. I got a rock. 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 I got a rock. I got a rock.
All right, so we'll go ahead and get started here. We're going to continue with strings and string exercises. That'll be your hack today as well. And then on next week, we'll move on to file I/O, file input and output, which basically is really, really easy because you've been reading input, you've been making output to the standard output. So it's exactly the same thing. It's just that you do it to a file instead. We left off last time with thinking about dynamic strings. Remember that regular strings are very limited, right? So you'll want to use, in most cases, malloc here in order to create a dynamic array that can hold a string. And when we do, right, we always need to make sure that we are, well, first of all, we need to make sure that we're doing a character array, of course. But we also need to make sure that we are accommodating that null terminating string. So if you're going to create a string, enough space to hold, say, 10 characters, you always need to add an 11th character for that null terminating string, okay? So we created this deep string copy function that allows us to make full copies, right? Did we actually use it? Yeah, we did here. So the University of Nebraska Omaha, and then we changed it so that we corrected the lowercase u here, and then we saw that the name and the copy were different because they were deep copies. What I want to do now is let's go ahead and, given a string, let's remove all white space from it. Right? And so now all white space are very special characters, right? Spaces, tabs, end-line characters, stuff like that. So let's go ahead and start with a prototype, or with a first run at this, basically, right? So let me go ahead and document it first to understand that what we're doing. This function takes a string s and modifies it by moving all white space from it. Right? For example, hello, let's say space HELLO space would then end up as hello, right? All those spaces, I would end up taking out those spaces, but I also want to make sure that I'm taking out end-line characters and tabs and other stuff like that, right? Now, I could put those in here as an example, right? Tab or an end-line character in here to indicate that, you know, I'm going to be removing that stuff, right? Note here that it modifies the existing string. So help me out with the at least the signature here. Void, right? Because I'm not going to return anything, right? That's one option. What should I call this function? Remove white space, RWS. That's a terrible acronym, right? Because it doesn't say what it does. So remove all white space. Right, there we go. All right. What should we take as input here? A string? What is this? Well, do we have strings? Nope. Char star s, right? Character pointer to an s. Now, I could put const in front of this, making just like I did with deep string copy, making the promise that I'm not going to change it. Is that something I want to promise? No. Not if I'm going to be modifying it, right? So take that away. Otherwise, I'm not going to be able to modify it. Now, let's rethink. The void is certainly an option, right? But if I'm going to do error checking, error handling, maybe I could use an integer here. Now, the input is very limited. What's the only thing that could go wrong with that string that we can detect reasonably? Null. If it's null, right? Then I'll go ahead and return a non-zero error code. If we had gone with our original idea here of void, I would simply just return without an error code. Which one do we want? This one? All right, since I've already written it. All right, fine. All right. Could I detect or s is not a valid string? Right? In other words, it's not a valid null terminated string. Is there any way for me to do that? Not really. The only way that I could do that is start at the beginning of the string and just keep going until I see a null terminating string. How do I know that I haven't gone out of bounds, though? Right? There's no way for me to determine that. If there were a way for me to determine that, strings would be very, very, very different in C. Right? You'd be talking about C++ or Java, where you have a full string type, where you don't have to worry about those low-level details. That's not how it works in C. Right? We can't tell if something is not validly null terminated. It's on us to make sure that our input is good. Okay? Okay, so ideas. Well, I could go across, you know, the input here and see, okay, I've got a space here. All right? So shift everything down so that it looks like this. Right? Move every single character over by one. All right, H, that's not white space, so I ignore that. Space, okay, I need to get rid of that. So shift everything down again. Right? Shift everything down again, et cetera, et cetera, et cetera. Right? Now, for a small string, that's not that big of a deal. HELLO, you're only shifting 5 characters, 5 to 10 characters or whatever. And if you've got only, you know, 5 spaces that you're removing, then you're only shifting 5 times 5 times, right? One space, you're shifting 5 things down. Another space, you're shifting 5 things down, shifting 5 things down. So 5 times 5, 25 operations, right? Not that big. But what if this is actual data? For example, like, I don't know, DNA data. It's a bunch of A's, G's, C's, and T's, right? What do those stand for? Adenine, guanine, cytosine, and AGCT, thymine, right? Something like that, whatever it is. Where we've got millions upon millions upon millions of characters. And we're removing white space. Say 10 million characters. and half of them are white space for some reason, right? 5 million. That 5 times 5 just became what? 5 million times 10 million. How big is that? 50 trillion, something like that, right? Now it starts to become noticeable. That operation then starts taking hours, days, weeks, right? That's not an option. Right? I mean, that's not an option for large data. And that's not even big data, by the way, right? Not in today's world, right? That's megabytes of data, right? That's nothing. Right? Nobody even measures hard drives in megabytes anymore. Nobody even measures main memory in megabytes anymore, right? All right, so let's rethink that, right? I don't want to that would be the brute force way of doing it. Other ideas? Okay, I could use that potentially. STRCHR is what you mentioned. I could use that potentially to find the first instance of the white space, but then I still need to get rid of it somehow. Right? I think it would be helpful if we had some temporary workspace. For example, if I had this string over here that just had a bunch of capacity, right? And now let's iterate over this string, right? All right, there's white space. Should I copy it over? No, because I don't want it. H, okay, that's not white space. Let's go ahead and copy that over. Space, don't copy that over. E, don't copy the tab. Copy the L, don't copy the space. Copy the L, don't copy the end line character. Copy the O, don't copy, don't copy, don't copy, and you're done. What should I put in at the end? The null terminating character. Right? Now, I've whiteboarded this up here, you know, as I was typing, right? What would that look like in code? I need some temporary workspace here, right? So let me go ahead and create a temporary string, and I'll call it temp, right? And I'll make it of size 100. Is that a good solution? It'll work for any string that's 99 characters long, right? Why? Why 99, not 100? The null terminating character. I'll give you a string that's 101 characters long and break this code. All right? Pump it up to 1,000. Right? I'll give you one that's 1,001 characters. Right? Pump it up to 10,000. I'll give you one that's 10,001 characters, right? We can both play this game back and forth until you finally lose. Can I create a static string that is 10 megabytes? No. Where is this located again? On the stack, in a stack frame. Your stack is limited usually, right? And we saw it before when we were looking at arrays. Our stack is limited to 8 megabytes. Can you fit 10 megabytes in there? No. You go to the top of the dishes, you put one more dish on, and it all collapses. We call that stack of dishes. You've overflown it, you've stack overflowed. All right? That's not going to work. So, okay, int n is equal to strlen of s. That tells me how many characters I actually need, right? I'm not guessing anymore, right? I'm not guessing, well, maybe it's less than 1,000, maybe it's less than 10,000, right? And oh, maybe it's less than 10 million, oops, stack overflow, right? I'm only getting exactly as much as I need. Now I need to set up my temporary string. Don't make it a static string, make it a dynamic string, and I'll call it temp still, right? Is equal to a call to malloc. Size of char times n plus 1 y again for that null terminating character, right? Make sure that your math is right, PEMDAS. The P in PEMDAS is parentheses, right? Okay. Now I've got a space big enough. Now what I'm going to do is iterate through this input string right here, s, right? Supposing that it looks something like this. And if I see a white space character, I ignore it. If I see a non-white space character, I'll go ahead and copy it over to temp here. How do I iterate over the characters? You did it in Tuesday's lab, an idiomatic for loop. For I equals 0, I is less than n. I'm glad that I put that into a variable, right? Because I can reuse that down here. I plus plus. For each character, let me outline it. If s sub I is not a white space character, white space character, dot, 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 then go ahead and copy it over. Temp sub something is equal to s sub I. Right? Okay? Now, how do I detect whether or not something is a white space character? I could do something like this. If it's not equal to the space character, and it's not equal to, I'm tired of typing already, the end-line character, and it's not equal to tab, and it's not equal to the carriage return, and it's not equal to dot, dot, dot. No. I wonder if there's a better way of doing this. Right, there is. There's another library called the C-type library. It does not stand for the programming language C, right? It stands for character types, right? And it provides a bunch of useful functions that operate on single characters. For example, the one that I'm most interested right now is space, C, right? It returns true if C is a white space character, right? Other convenience functions would be is upper of C, right? Returns true if C is an uppercase letter, right? What else do you think we have if we have is upper? Is lower, right? And it returns true if C is a lowercase letter, et cetera, et cetera, et cetera. You can even, change things, right? You can go ahead and get the, convert it to uppercase or to lowercase. Is it a digit, right? And these are only a select few, right? How would you know what else is in the C-type library? RTM. Read the manual. Bring up Google or better yet, DuckDuckGo on the C-type library, and you can read all of them that are in there, right? Is punctuation is in there, right? Is punct, I think, is the shorthand, right? So over here, I'm not going to go ahead and do all that chaining of is this, is this, is this. I'm just going to go is space, right? And remember, if it's not a space. So how do I negate something? Exclamation point. If s sub I, the ith character in s, is not a space character, then go ahead and copy it over. And before I forget, now that we're using this library, what do? We need to include it. The C-type library. Okay. Come back over here. I still have a question mark here, right? So if I align these two things up, this example up here, right? Let me go ahead and come back over here and start over here. So when I copy H, when I copy E, when I copy L, I am looking at the current the current character up in one string, but does that necessarily correspond to the character in this string right here at the same location? No. So if I'm going to use I as an index for the first string, I don't use I for the index of the second string. I need another index to index the second string. Okay. Again, I'm just whiteboarding this stuff. So I'm going to go ahead and go with J. Why? Because it comes after I. Right? And I stands for index. Okay. So let's go ahead and create that variable. I is equal to, or J is equal to 0. Y, we start at 0. Right? Anything else that I need to do here? I is moving, yeah, but J needs to also increment. So J++. Nope. That would go J++ every single time, along with I++, right? I only want to go J++ if I've actually copied something, right? So ignore it, move on. Ignore it, move on. But if you do need to copy it, but both of these then need to move on, okay? Is this string the temporary string now? Is the temporary string validly null terminated yet? No, because we didn't use strcpy, we didn't use strcat that takes care of those things for us. We did our own manual algorithm right here where we're copying character for character for character. So null terminate it manually. Right. Temp sub j is equal to the null terminating character. Now, why was I able to use j here? So suppose it copies over HELLO, right? 0, 1, 2, 3, 4. All right, what's J after it's done copying everything over? 5, and that's exactly where that null terminating character needs to be. All right? Okay, great. Now what? What I've done is I've successfully removed all the white space from the original, and all the white space has been removed in the temporary string. Right? Does that change the original string at all? Nope. But what could I do now? I could copy it over. strcpy into s temp. Right? And then return. Am I done? Think about that for a second. Let's come down over here, and let's go ahead and remove all the white space from, let's see, I changed the copy. So let's remove all white space from copy. There we go. And then we'll print out the copy again. Making sure that I designate it. And another trick that I like to use when I'm doing ad hoc testing on strings is to surround it with a special character like a pipe, so that if there's leading white space and trailing white space and stuff like that, then it's absolutely obvious that it's there, right? Because if it just goes to the next line, you don't know if there are a bunch of spaces that have been printed at the end of that line. But by surrounding it with pipes here, or maybe even quotes, right? Here's your string in quotes, right? But is that going to work? Nope. Strings start with quotes and end with quotes. So this string has been ended as of this. How do I get around that? Escape them. There you go. Or use single quotes if you want to within double quotes. That works too. All right. Lecture CSCE 155. Or sorry, 194. Or ECN. There we go. GCC demo. All right. Now, if it worked, we should have that the copy is University of Nebraska, Omaha. No white space. All those spaces have been removed. What else should I probably test, though? Leading white space, tab characters, endline characters, maybe a tab character inside here, right? There we go. And GC, yeah, this is what I want to do. A dot out, and there. Looks like, yep, it worked. I successfully moved all that garbage white space from it. Question?
Do you care about, no, I guess it goes through the original string, like if you were to print out after what the null terminating character is, wouldn't it still have like the old stuff in it?
Yep. It'll have garbage in it. There's no way, there's not an easy way, there's not an efficient way for me to contract memory. You can do that using realloc and say, okay, I'll reallocate this memory and give a little bit of it back if you want to. There's no point though. Right. But there is, I mean, it looks like it works. Right? Could there be some bugs that are not manifested themselves? Let's find out by using the tool Valgrind. Uh-oh, 2 errors. All right. So I wonder what the errors were. It's not giving me any line numbers. Why not? I got to compile it with the G flag. And what else should I have done from the beginning? The wall flag. All right, so nothing comes up with wall. All right. Now when I go Valgrind on this, then I see a leak summary of 70 bytes have been lost. All right. So one of those things that's being lost is the copy itself, and that's a red herring because it's in the main. Right. I can go ahead and free that up, copy. And this will take it down, I believe, to only 35 bytes that have been wasted, which should be a hint. Yeah. What else is being wasted and where? Remove all white space. Line 31. Let's jump up there. We create that temporary variable, or temporary workspace, so that we can copy over the contents without any white space in it. Then we just simply copy it back into S. But then what do we do with temp? It's still there, and it's leaking memory. Once you're done with it, free it up. Right? Remember, who's responsible for memory? If I'm a function now, if I create memory and give it back to you, like malloc, you become responsible for that memory. But if I create memory and don't give it back to you because I was using it for temporary workspace, right? Temp, that's what why I called it temp, then I'm responsible for taking care of it and freeing it up. Now when I run this again, after I've recompiled it, there should be no memory leaks at all, and they're not. Okay, excellent. Remove all white space. What was the other one that we wanted to do? Given a string, count the number of characters. Right? We could do that. Right. So int count chars. Right. What else did I have? Removing spaces, then substring. Okay, yeah, we got plenty of time. Let's go with char star s. All right, so all I'm going to do, and then another character, char c, right? All this is going to do is iterates through the given string and counts up the number of occurrences of the given character c, given string s, and counts up the number of characters. Okay? So immediately, I'm going to return an integer, of course. Now, immediately, do you see an improvement that we can make? Const, because I'm not going to be changing the string. By the way, the lack of a const keyword is also a strong hint that this is going to change it, right? Because it can change it. The lack of a const keyword is just as informative as the const keyword itself, because it's saying that it probably will be changing this string. Right? But we're not, so let's make it more accurate and say, make the promise that we're not. Right? Okay. All right. So error handling. First thing you do, if s is null, right? Can there be a problem with the character c? Not really. You could give me a bad character, like a negative value, right? But that's not printable. I'll never find that in a valid string. So not really, right? So what should we return? Okay, we return 0. Why now? I thought 0 meant no error. When this is an error code, then yes, 0 means no error. But this is not an error code, right? It iterates through the given string and counts up the number of occurrences of the given character. If I used 0, 1 as error codes for returning from this function, right? Then how could I determine whether or not? Well, I gave you the word, the string hello world, and I asked how many x's are in it. And there are none, right? How do I distinguish between the fact that there is no error and versus the fact that there are no characters in that string of that type? Right? I can't. So I would either need to redesign this function, or in this case, 0 is not an error code, right? How many x's are in the null string? 0. How many y's are in the null string? 0. How many capital C's are in the null string? 0, right? It makes sense. So we're doing error handling, but we're not just necessarily doing error codes. Okay? All right. So another idiomatic for loop. For int I equals 0, I is less than n. You can put that into a variable, or you can just go do it here, strlen of s, I++. And then if s sub I is equal to that character c, then count plus plus. Oops, I forgot my variable to count. So I'll go ahead and do that now. There we go. And then return count. All good? No, what's wrong? Yep. Always initialize your variables. Otherwise, what was in that variable before? Mystery, garbage, dead beef, right? Garbage plus 1 is still garbage. Right? All right, good. Now this has got me thinking. Now this is really under the hood thinking here, but I need to know how many how many characters are in the actual string in order to iterate over each character. In other words, what I'm doing here is I'm doing the same work twice. The way that strlen works is by simply iterating through all the characters and with a counter until it gets to the null terminating character. So if there are 1,000,000 characters, I do roughly. I mean, it's a little bit optimized, so, and under the hood, it's a little bit better than that. But I end up doing 1,000,000 operations to count up the number of things that there are. I start over again with this for loop, and I do another 1,000,000 operations in order to count the characters that I'm actually interested in. So you can do it like this, and for the most part it'll be okay, but you'll be doing twice as much work. Is there a better way? Maybe a while loop instead. Right? I'll put the I outside, starting at I, and while I, or S sub I, is not equal to the null terminating character, keep going, right? So if that's the character that you're searching for, then increment the count. Otherwise, I++. Just go to the next character. Regardless of what you find, go to the next character. Now this while loop looks a little bit more complicated, right? But it's actually more efficient because instead of doing 1 million things twice over, 2 million things, you're doing only 1 million things once, right? If there are a million characters in there. Right? Those are the kinds of things that you have to be aware of when you're, say, on an embedded system, or efficiency then becomes an issue, right? You know, you can get away with it for the most part if you're just doing high-level programming stuff. But if you're doing system-level programming stuff, you can't afford to be doing things twice over every single time. Right? You don't have the CPU cycles for it, even in 2022. Right? Let's test it. Before I free it, of course, let's go ahead and count the number of characters. Int x is equal, result is equal to count chars of copy, and I don't know, copy the number of capital O's. There we go. Print f result is equal to percent d and the line. How many O's are in that copy of the string? Did I fix it? Oh, I didn't. Okay, well, whatever. Result. There we go. There should only be one, right? Omaha, right? Oh, count chars. There we go. Makes sense. There should only be one. What about eyes? Right, again, ad hoc testing here. What would you? I see 1, 2. That's it. There are 4. Just 2. Yeah, there we go. Oh, okay. Yeah. That's printed out once. Printed out twice. This is the actual string that I'm actually counting here in the copy. A's? Is there anything more? What's the most common letter there? A? 3, thank you. I'll trust your math. Let's find out if your math is right. Oh, 4, you got it wrong. What is it? Where? A. There we go. There we go. Cool. All right. Maybe one more exercise, and then we'll look at data processing. All right. This exercise that I want to do is, did we do substrings? Oops. Oh, I don't want that. Find substring. Yeah, we did. All right. So remember, at some point we talked about substrings, right? This thing right here, right? What we did was I had my full name here, and I wanted to isolate my middle name. Okay. And the way that we did that was by jumping to the character where M started, right? The 13th character, because we start indexing at 0. And so index 12 starts at M. And then I changed that into a char star to make it into a string. And then I said that I only wanted to copy 7 characters over. Let's use that idea and put it into a function so that we can reuse it. Right? So what I mean by that is, let's write the following function. Substring. This function takes a string, s, and 2 index values, start and end, and creates and returns a new string that is the substring of s, containing characters from start to end. It always helps in your documentation just to good in your own mind. It's not absolutely necessary or required or anything, but sometimes it's helpful, like we did up here when I was walking you through a potential solution for remove all white space, right? Sometimes it helps to write one out. Force yourself to write it out on a screen or a piece of paper or a whiteboard or something like that, so you can walk through what a solution might look like. Right? It helps to put it together in your own mind, right? That's part of rubber duck debugging. Right? Right. There we go. All right, so let's look at an example here. For example, if I've got an input string, say, I don't know, hello world, right? And index values start is equal to, say, let's say 0, 1, 2, 3, 4, 5, 6. 6 through 7, 8, 9, 10. 10 would give back world. Right? So do you see what I'm doing there? Right? This is the 6th one, and I'm going up to and including the 10th, index 6, up to and including index 10. My numbers were correct, right? Think so? Okay. We could always put it in a Python tutor or something, right? So what's my return type going to be here? If I'm returning a new string, what is a string? A char star, right? Just like we did up here with deep copy. Right? In fact, wait a second. You know what? I'm thinking remove all white space. That screws up the original data. What if we wanted another version, right? Char star remove all white space from a copy, const char star s. Right. What would that look like? Would I have to rewrite that entire function? No. I already have a function to do that, right? So write one of these functions and make the other one call it, right? I could make a deep copy and then pass it off to remove all white space and then return that new copy. Right? But in fact, that has me rethinking the design of this function. Right? Which one of these functions should call the other? Right? Remove all white space versus remove all white space copy. I'm essentially doing the copy already with temp. Right? So maybe I want to redesign both of these functions so that remove all white space calls remove all white space copy. Okay? I'll leave that as a to-do. Right. Just to get it to compile here, I'm going to return null. Right. To-do, implement. Right. That's always a developer's best friend. Just put it in to-do and let somebody else do it later. Right? I don't want to do that right now. Let's go back to what we are actually doing. Right? It's your best friend because, you know, if you get this thought in your mind, I always have this problem personally, that I always think of something and then I think in the back of my head, don't forget, don't forget, don't forget. I always freaking forget, right? So what do? You write it down, right? So usually I think of one thing, two things, three things, and then, oh crap, I can't remember three things long enough to even get to a piece of paper to write it down. So you start repeating them over in your head, right? I've got three things to remember, this, right? Shorthand, shorthand, shorthand. And then you finally, this is the way I work at least, then you run to a piece of paper and write all three down before you forget, right? Maybe not everybody works like that, but that's why to-dos help generally, right? All right, substring. What am I going to take as my input here? Another string. And I'm not going to be making changes to it, so it'll be const char star s. And as the documentation says, an index value called start and an index value called, index value called end. Okay? So let's do some basic error checking here. If s is null, right? Or what's some other, now that we've got other things here, some other things could go wrong, right? What about that start index? Can't be negative. And it can't be greater than, oh, okay, so it can't be greater than end, right? It could be equal to, right? Because then I just want a substring of size 1, right? End and begin right there, right? It's kind of stupid. If you want a character, just take a character. But we'll allow it. What else could be wrong with that start? Start is bigger than the length of the string, right? So how do I determine what the length of the string is? strlen, right? That has me now thinking that maybe I should split this up because it's getting a little bit long. And also, am I going to be able to call strlen on S if it's null? No, so let's just go ahead and immediately return if it's null. Right? Return null. Why did I return null? Because that's the only thing I can do, right? Could I return 1? Something happened. Nope, that's the memory address 1, right? I've created your substring for you. Go find it in memory address 1. No, that's not how it works. Null. Right? Now what I can do, because I'm going to want this later, by the way. This is why I'm splitting it up. Now that I know that it's a valid string, let's go ahead and capture that value n, right? And do some more error checking. Right? So if the start is less than 0, what about the end if it's less than 0? Or end is less than 0? Oops. End is less than 0.
You don't have to check for that.
Say what?
You don't have to check for that.
Why?
Because you checked start.
Ah, okay. I like that thinking, right? That if they're out of order, right, then I don't have to check on the other end. No, it could be that one is -10 and one is -5. Well, then start would be negative. Okay, yeah, I buy it. All right. What do I have to do with respect to end then?
Check that it's not out of bounds or not far end.
End is greater than the string length? I don't know. HELLO, again, an example. Whiteboard it. 0, 1, 2, 3, 4. The end can be 4. But can it be 5? Nope. So greater than or equal to. Sorry, end. There we go. If end is greater than or equal to, and I don't need to call this twice because I put it into that variable already. Right? So 5, right? If you're saying I want to go to all the way to index 5, 0, 1, 2, 3, 4, that's an invalid index. Okay? Return. What again? No, because that's the only thing you can turn. Return. Right? All right, next. Want to create a new string of size, ... What would be my size? So that would be the size of the original one, right? So again, this is why we whiteboard things with at least one example. This is why when we give you a handout telling you we want you to do this function, here's at least one example of how it works, right? So that you can walk through your solution with that kind of test case in your mind, right? It's kind of like the testing that you do even before ad hoc testing, right? It's the testing you do when you design the function, when you actually implement the function. In this case, I want world, W-O-R-L-D, 5 characters. How does 10 and 6 give that to me? 10 minus 6, that's 4. Is that enough? No. So 10 minus 6 plus 1, right? Plus another 1. Why? For the null terminating character, right? So 10 minus 6 is 4, plus 1 to get W-O-R-L-D, plus the null terminating character over here. So how big do you actually want it? Int new size, say, is going to be the end minus the start plus 1. I'll take care of the null terminating character when I actually make a call to malloc, because that's a little bit more idiomatic, I guess. All right, so char s, can I call it s? I've already got s over here, so what should I call it? Substring? That's what it is. But what's this function called? Substring. 99% of the time you can get away with a variable having the same name as a function. There's 1% of the time that that's not going to work, or you get confused, especially when we get into function pointers later in the semester. Right? You'll start assigning values to a function accidentally, and when you do that, then it doesn't compile, or it all comes crashing down. Right? So as a general rule, it's good to, at least for local variables like this, to stay away from the same name. Right? You're going to get confused. Which one's a variable? Which one's the function? For that reason, that's why as a general rule, functions should be called verbs. Right? Get substring. Right? And a substring, substring, is a noun. Why? Because functions do things, use verbs. Right? Variables are things, use nouns. Right? Okay. Generally, right? Now, you'll see that that's not the case in a lot. There are going to be exceptions to that guideline. Again, it's not a rule; it's a guideline. Right? So, char star, a call to malloc. Right? How big do we want it? Size of char times new size plus 1. Plus 1 here for the null terminating character. Okay. All right. Now what? Could I do this? strcpy into the substring s. That's just a blind copy, right? That's going to be trying to copy the entire hello world exclamation exclamation point into this string over here. That ain't going to work. First of all, I want to limit it. I only want to copy 1, 2, 3, 4, 5 characters, or in this case, new size characters. That means I want strncpy, the byte limited version of that. Now, let's go ahead and test this out and see if it works. Return substring. Let's see. Here's the, you know what? Let me go ahead and put in the original here without all that stuff, because we already tested it. But now you see the value of formal unit testing, right? And having a formal unit testing framework. I'm going back and I'm changing things in order to test other things. Going back and changing, maybe I broke something, right? If I had used a formal unit testing framework from the beginning, I wouldn't have to be going back and changing things. I would just add a new test case, and I'd have all the old test cases that I could run again to see if I broke anything, right? I want to isolate, say, Nebraska, all right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? I guess it's my notes, right? That's, nope, that was my name, never mind. All right, so 14. I want the substring starting at 14. So get substring of name starting at 14 and going all the way up to and including, let's see, that's what will be 14, 15, 16, 17, 18, 19, 20, 21. Up to 21. There we go. Char, and that's Nebraska, so it's char star state. And then let's print out state. If this works, I should be getting Nebraska, right? It ain't gonna work though, of course, because we're not done. Right? D, there we go, S, and this is state. Oh wait, no. State. S, state. There we go. State. All right. Universe. Y. strncpy s into substring starting where? Starting at the beginning. I don't want to start at the beginning. Where do I want to start? At? That's why I called it start, right? I want to start at start index. Now, is that going to compile? No, because this thing is a single char. How do I change it into a char star? Ampersand. Good. There we go. It'll compile. Does it run? Should get Nebraska. I might be off by 1. I'm not sure. Oh, cool. Now, again, another trick that, again, the trick that I like to use is to surround everything with double quotes here so that, okay, good. I didn't have like an extra space in there or something that I didn't see, right? Excellent. Yeah. So, let's go ahead and run down what each one of these things are. So what is S? S is a char star, a string, right? Right? So when you index S, say, I don't know, whatever it was, 14, right? You are referring to one element, right? One element in S in S is a char, or sorry, char, not a char star, right? So to get the string starting at S14, right, you use ampersand, making a char into a char star. Python tutor. Let's take a look. So if I create a string here, char foo is equal to go mavs. There we go. Right, and I create a single character, C here, 0, 1, 2, 3. So foo sub 3. That'll be the capital M, right? We're going to visualize this. Now if I go with another S, a star S, and I make it point to foo sub 3, right, by putting an ampersand in front of it, what does that look like? There we go. So there's go mavs in a string, right? And the null terminating character is even over there. When I refer to a single character, right, then I'm getting that M. But when I make a pointer to that character, that right there, I'm getting a pointer right there. It's as if that string had started at the M instead of at the G, right?
Thank you.
Okay. Nice little visualization tool here. Okay. All right. I think that that's everything. Of course, free state. State. There you go. Last thing that I would want to do, of course, is run it through Valgrind just as a last sanity check to make sure that there are no memory leaks, that there, you know, oh, there is an error. What is it? There's no memory leaks. Oh, okay. Good. Conditional jump removed depends on uninitialized values. Uninitialized values. When we were trying to print 128 state, well, state came from this function right here, so there's still a problem. There's still something rotten in Denmark, right? Not a problem in Denmark, right? So there's still something wrong with this. Let's try to walk through and find out what. Right? Okay. So we create a new size. I'm reasonably sure that that's correct, because otherwise we would have gotten, we would have been off by one way or the other. We got Nebraska. We got the thing that we wanted. Right? I'm also reasonably sure that we made way for the null terminating character. Right? I'll go ahead and leave this in here when it posts to the notes. You can, if you want it. Right? But oh wait, I seem to remember strncpy. What was the documentation on that? Man, strncpy. Right. So strncpy is similar to strcpy, except that at most n bytes are copied. Warning, right? That's why it's in bold. If there is no null terminating byte among null terminating character among the first n bytes of source, the string placed in destination will not be null terminated. That's what that warning from Valgrind was telling me, yelling at me for, right? Unfortunately, it's not as sophisticated enough to say, by the way, on line 104, you should have null terminated that because strncpy doesn't do that for you. It just knows something went wrong somewhere, right? So, help me out. What do I do? Substring sub something needs to be the null terminating character.
It's just new size.
New size. Why? If it were HELLO, where does that null terminating character belong? 1, 2, 3, 4, 5. 5. Index 5. Right. Nope. New size. Right. There we go. GCC. Valgrind this. And, oh, nice. 0 errors, 0 contexts. Okay. Oh, okay, there's a question, unrelated to what we're doing right now, but there was a question online about, would you mind briefly explaining how the tic-tac-toe game picked the best move in option 3? So it was AI written. All it's doing is simulating every single possible game, right? There are only 9 squares, so it makes a decision on, okay, well, among these 4 available slots, what if I did this one? 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 And then what it does is it does what's called a recursive call. We'll look at recursion very soon, actually. But basically it says, okay, well, if I did that move, now I've got 3 more choices. What if the other guy did that move, did that move, did that move, right? Each one of those is another recursive call, right? And so let's consider this one right here. All right, well, I did this move, they did that move. Now, what would happen if I did one of the other moves, right? It basically simulates every single possible game, of which there are only not 2 to the 9, right? Why? Because there are only 9 slots. You can go X or O in each one, so 2 to the 9 is only going to be like 512, right? There's only 512 possibilities. It just looks ahead to all of them. If it sees a winning sequence, it will choose that move, right? If it doesn't see a winning sequence, it will choose a move in which there is at least a tie, right? So it will always play, I mean, if you're dumb about it, it will always win. But if you're smart about it, it will also be always smart about it and always play you to a tie, because that's what tic-tac-toe is, right? It's a solved game. It's a stupid game, because if both actors are rational, you're always going to play to a tie, right? Okay? Oh, yeah. What? No, no. That was the premise of the final scene of the, what was the movie? War Games, thank you. War Games. Right? Which is kind of stupid, because a supercomputer doesn't need, you know, hours to determine, oh, this is an unwinnable game with tic-tac-toe, right? You play yourself, right? You find out that you can't win. Right? Again, there's only 512. Even 1980s technology could go for 512 possible games in a matter of seconds. And by the way, the vast majority of those are invalid. That includes games where X made 3 moves immediately. So the number of actual valid tic-tac-toe boards is extremely small, right? And now take them all and rotate it, and you get the same exact thing. Rotate it again, divide it by 4, right? And now it's even fewer. I think that there are probably only maybe a few dozen valid game scenarios. So it's a very solvable game, right? Unlike chess, unlike Go, right? Which have that's how AI programs for chess work. But instead of looking ahead 512 moves, they look ahead millions and billions of moves and use a heuristic that says, well, if I make this move, then in 90% of the cases, I will have a better game board 1 million moves away. And that's why it makes that best move. Right? No human can ever beat, at least now as of today, no human can ever beat that kind of look ahead. Right? That's what there's a chess master that was accused of cheating, right? Yeah. Of using one of the supercomputers to make their moves, right? And they were found out because of the network lag or something. They started suspecting him because there was network lag. It's okay. It's still up for debate, of course. I guess we'll never know. Oh, how would he have cheated in person?
There's a lot of theories, but one of them is like he had like a little seed on his person that would like vibrate.
Oh, okay. So the classical, card counter trick where somebody else is looking at the cards and they signal them. Okay.
But they haven't found any definitive proof.
Okay. All right. Anyway. One last thing today. We'll do it today. One last thing, because it is important. Tokenization. So when you're all the stuff that we've been doing up to this point has been on toy data, My Name or University of Nebraska or Go Mavs or something like that, right? Strings usually represent real data. Real data can look something like this, right? Right? There's my first name, last name, so I'm still using my name here, my NUID, city, state, and office, right? And then we've got Margaret Hamilton at 1234 Lincoln Street, whatever street, Lincoln, Nebraska shore, Joe Smith in Atlanta, Georgia for some reason, right? So what kind of data is this? Does anybody recognize it? Like if I put this into a file and I double click this, yeah, it's CSV data. What application on a Windows machine would want to open this thing? Excel, right? So formatting data, one of the most common interchange formats is going to be CSV data, right? Each item is called a token, right? Each line is called a record. Because if you were to open this up in Excel, how would it render it? Well, it would have these headers. The first column would be first, the second column would be last, the third column would be NUID, etc. And then it would separate each one of these tokens into each one of these records into one line in Excel, and and put each one of these tokens into their appropriate column. Right? This is CSV data. Right? Splitting up this data along their tokens is called tokenization. Okay. Now, I will say that this is very common data format. It's not the best kind. Right? There are plenty of other data formats that are much better than this, that provide semantic meaning to the data. For example, I don't know, CSV to JSON converter. I'll just show you what it looks like. I'm going to take that CSV data there and convert it. JSON is another data format, right? It's text. All these data formats, by the way, are text-based. And this one stands for JavaScript object notation. Even though it says JavaScript, it's such a handy little data formatting tool that it's used in practically every language. Every language has some library to support JSON data. Right? So the way that it works is we've got an array, square brackets. We've got objects, curly brackets. We've got what are called key value pairs. So the first name here maps to the first name in double quotes because they're all strings. Right? The NUID, that key, maps to a number. No double quotes here because it's a number. It's being interpreted as a number, right? Comma, here's the second record. Comma, here's the third record. Right? As of, well, whenever JSON was invented, I think maybe 20 years ago, maybe more, this has become the most popular data interchange format. EDI is electronic data interchange. Right? If you're just, rather than a CSV file, people prefer to use JSON instead. Prior to that, they would use XML. Right? They still use this widely, but JSON seems to be a lot more popular now. Right? Let's go ahead and show you what that looks like. There we go, down here. Right? So this has semantic meaning. So the root element, I would actually call that, I don't know, people, right? And the row elements, I would call person, like an individual person. One record begins with these markup tags, Langle Wrangle, and then the thing that it represents. This is a person. This is their first name, right? And anything between that tag and the closing tag here is their first name. Anything between that opening last tag and that closing last tag is their last name, right? So this has semantic meaning. Over here, the CSV file had semantic meaning, but it was all located in the first row, right? And you had to make sure that this token lined up with this token down here, this token lined up with this token down here. And good luck to you if any of your data contains, say, Oberk, right? Or Chris, or, you know, Chris, like, I don't know, Chris, comma, or something, I don't know. What do I want? 123 A Street, apartment 2. Apartment 2. What did I do there? A comma is part of the data itself. So that screws up my tokens. That leads to, okay, well, now I need to escape that, right? Well, now I need to escape other things. And I need to escape other things. Basically, there's a not never ending, but there's way more complex than I'm making it out to be here, right? And this is very simple data. It's very clean data. If you get into real data, it gets real messy real quick. At which point, if you're going to process data like this, certainly if you're going to process data that's JSON data, and absolutely if you're going to process XML data, you are bringing in a library to do it. Right? But what we're going to do is keep it simple. And let's go ahead and look and see what tokenization would look like in C. Okay? The way that you do this is through a function called strtoke, right? Short for tokenization. And what you basically you want a string that you want to tokenize, that you want to split up, right, into the first name, the last name, et cetera, along some sort of a delimiter. The delimiter in this case, because it's CSV data, your delimiter is comma, right? Let's just go ahead and jump into it right away here. I'm going to get rid of all of this. I'll make sure that you have the rest of it in the notes here, but char data, right? There we go. I want to split this up. I want to tokenize this. So I'm going to make a call to call strtoke the first time. To do that, I use strtoke, right? And the string that you want to tokenize and the delimiter that you want to use. I'm using double quotes here, even though there's only one character. We'll talk about that next time. Basically, you can have additional delimiters here, right? Semicolon, a tab, TSV data, tab separated value data. And that's a pain in the butt for Excel, right? All right. So the first time you call it, it actually returns a pointer, char token, right? So call it for the first time, right? It returns a pointer to the first token. ... Let's go ahead and print out that token. Printf token is equal to %s and the line token. Okay? Let's run this and show you that it works. All right, just a.out. There we go. There's the first token, Chris. Right. Call it again. Each call after the first, you don't provide the string, just the delimiter. So token is equal to strtoke, null for the string, because I'm giving a signal to this function. Keep tokenizing whatever string you were tokenizing before. If I did the same string again, it would start over at the beginning of the string. Right? So I want null. Right? And then, of course, the same token here. Right? And let's print it out again. Right? There we go. Let's do it again and again and again. Right? There we go. Chris Burke, my NUID, Omaha, Nebraska. Let's do it one more time to get that last token, 103 Shore. That's my office over in Lincoln. Right? Excellent. What do you think would happen if I did it one more time? Ah, good. Why? There are no more tokens, right? You got to the last one. So what does that say about token strtoke when it gets to the end and there are no more tokens? It returns null, right? So for it returns null if there are no more tokens. That means, should I be copy pasta here? Probably not. I want some sort of a loop. If you know how many tokens you expect, you can go ahead and put it into a for loop. But if your data is corrupted and you expect 5 tokens and there are actually 6 or only 4, you're in a bad situation. So let's go ahead and go with while. Token is not equal to null. I will go ahead and print out the token. I already printed that one, so let's go ahead and do it this way first, and get rid of all this. Okay. GCC. Run it. There you go. All right. I got everything except that. Wait. Why did I get that last null token there? So it's still it's not null yet, and I go one more time, right? I've got 103 Shore. That's not null. So I tokenize and I get null, and then I print out null. So let me go ahead and change the ordering of this stuff. Right? Don't print it the first time. There, now I'm not off by 1 anymore. There's all the tokens. Right? While the token is not null, print or process the token. process the token, right? Dot, dot, dot. Whatever, I'm just printing it for now. But if you actually needed to process this data for whatever reason, right? Then you would process it here and then set yourself up for the next loop. Okay? Questions on that? Otherwise, we'll get more practice next time. Okay? By the way, you should not need strtoke for hack 9 this week. All right? If you're thinking that you want to use strtoke, you can, but you're overcomplicating things greatly. All right, I'll see you in lab.